Hi, my name is Matt Maxwell, and I'm a product manager for the Tektronix Spectrum Analyzers. And this is a quick how-to video for checking a wireless LAN device for EMI pre-compliance. EMI is a broad topic. There's EMI compliance requiring anechoic chambers, antennas, masts, turntables, line impedance stabilization networks. We're not going to go into that detail here today. Really what we'd rather focus on is EMI compliance testing. So for EMI compliance testing, all you need to have is either a quiet RF environment or a known RF environment, so you can exclude known large signals, for example, signals from the FM broadcast. So to do this EMI compliance, pre-compliance checking, I have with me an RSA 607A. It's a real-time spectrum analyzer that's USB controlled with the USB cable here to the PC, running SignalView PC software. And my device under test here is a demonstration board with a BNC cable. Obviously, in a real EMI pre-compliance check, you'd have other antennas, potentially a directional antenna, so that you can measure the environment with the signal being turned on and turned off to get a better idea of the EMI signature prior to going for final EMI compliance check. So let's get started. What I'm showing right now is a spectrum analyzer trace. It's in a same frequency where I have the wireless LAN module transmitting at channel 1 of the wireless LAN band, 2.412 gigahertz. And I don't see any signal present, so the next thing I will do is turn on a trigger. So the trigger makes sure that I capture the signal, and I need to adjust the levels to get rid of the overrange message that was appearing on the screen. So I've adjusted the level to 0, the reference level to 0 dBm for basic spectrum analyzer controls along the bottom. I adjust the reference level, change the reference level to make sure that I have the correct level of the signal. And that's great. Now I have a signal present. I know that much is working. So when you're doing radiated EMI tests, there's radiated test and conducted test. We're not really going to talk about conducted tests in this particular video. We're focusing on radiated emissions. There's basically two major groupings of checking to do. One would be complying to the wireless LAN IEEE 802.11 standard for checking the spectrum close in to this ISM band, making sure that you don't run afoul of the limits set out in the IEEE standard and you're not sending out extra signals or too high of a signal level outside of the intended band. And then you're also looking for a broader range. So for the first check here, for looking close into the ISM band, I need to go to the wireless LAN analysis spectrum emissions mask. So there's a series of folders within the software, the SignalView PC software, and I find the spectrum emissions mask here, which is going to be already set up for the SEM test. And I may need to adjust the reference level a little bit more to make sure that I still trigger and I have the range set up adequately. Now the reference level settings may be called out in the particular test that you're trying to do, but basically I'm overranging, so I maybe -5. I need to avoid an overrange message because an overrange indicates I'm not controlling the instrument correctly. So I went down to -10 dBm for the reference level at first, and that was too low. Now I back off from the overrange to go to -5 dBm for the reference level, and I clear the reference level or the error message, and I also have a pass indication on the upper left for the spectrum emissions mass testing. So this is basically just configuring the spectrum analyzer to test for the output level across this 100 megahertz span in this case, to be able to ensure I pass the radiated EMI pre-compliance checks. Now I have a small failure there momentarily from the spur that came out of the signal there, but make sure I pass that. Now there's some other controls that I might want to do to change the spectrum emissions mask. So I have the measurement frequency, the type of measurement. I can use a peak power here, which is what I'm doing. It's a more conservative check, and that's what's called for in the IEEE 802.11 standard. I can do some other things like some averaging if I need to across multiple sweeps. That'll get a more stable reading, but it may not help me when I'm trying to pass the final testing. I have to test the signal in the way that's prescribed by the standard. If I needed to change the SEM mask, so I've got a reference channel, I have a table here that defines each of these 4 zones that are enabled, where each zone has a start and stop frequency. It's either both sides or left or right here with a drop down. Each one has a resolution bandwidth, and a video bandwidth is being used here. And the mask can either be relative or absolute. In this case, it's relative, that's called for in the standard. And start and stop frequencies and levels for each of the zones is all spelled out in that table. I can save one of these and take it offline in a CSV format, make some changes, and load it back into the software if I want to do my own type of mask, rather than using the default mask that's in the analyzer. So in the next step, I want to pull up the spur search and do a broader sweep for a wider range of the frequencies to check to make sure that I have a conservative check for EMI pre-compliance. So I go to RF measurements for one of the displays and select the spurious measurement. And it's not terribly interesting at first. So the way this display works is I also have ranges and limits similar to the spectrum emissions mask, but I will load a FCC limit file that has many of these limit lines already set up. So if I run this, oops, I was waiting for a trigger condition, so I need to turn on the trigger. Sorry, turn off the trigger. Once the sweeps, it clears. So now I'm looking at a 7.5 gigahertz sweep, and it's passing. I'm looking for all spurs that fall into the definition of the spur that I've set up in this table. So here's the spur table here that we can show while this is performing measurements. I'm looking at 4 different zones, their start and their stop frequency. Now for affecting this EMI pre-compliance test, I'm using a CISPR shape filter with a plus peak detector. And there's the other detectors that are visible there. And there is a different RBW in the zone D, the 960 megahertz to 7.5 gigahertz frequency band. Uses a 1 meg RBW versus the other frequent RBWs are 120 kilohertz. There's spurs, thresholds, and excursions set up in the table, as well as the absolute limit lines called for in the FCC Part 15 mask. So hopefully now you have a little better understanding for the capabilities of this RSA spectrum analyzer to do EMI pre-compliance checks with the spur search to make sure you have a reasonable chance and better confidence for passing final EMI compliance. I thank you for your time.